Let's find the equation of some lines. So let's say I have the point 1 minus 1 with a slope of negative 2/3. To find the equation of this line, all I have to really do is fill in my point slope formula. Y minus y1 is equal to m times x minus x1. All we need to find the equation of a line with the point slope formula is one point and a slope. And we have each of those things. So now it becomes a very simple problem. Take our formula and we just put our relevant information in. Minus 2/3 for the slope, x minus x1, which is 1. And now all we do is simplify. Y plus 1 is equal to minus 2/3 x plus 2/3. Subtract 1 from each side. Y is equal to negative 2/3 x minus 1/3. And this is the equation of that line that passes through the point 1 minus 1 with a slope of negative 2/3. The next problem I have is very similar to the one we just did, but there is an additional step. So let's find the point, or let's find the line that passes through the points minus 1, 2, and 1, 3. And we can see some similarities to the problem beforehand, where we had a point and a slope, and we just put them into the formula. Here we have 2 points, and we don't have a slope. So we need to get a slope. And with 2 points, we can get a slope with the slope formula. So slope formula again, m is equal to y2 minus y1, x2 minus x1. And remember that the slope formula is just the point slope formula rearranged. If we multiply this bottom part over here, we have the slope formula. So it might not even be necessary for you to remember that formula if you can remember this one. And remember that this multiplied to the other side is the same thing. But anyways, let's just find our slope. y2 is 3, y1 is 2, x2 is 1, x1 is negative 1. That leaves us with 1/2. So our slope is 1/2. Now that we have our slope, we take our slope and we can use either one of our points to find the equation of the line, because both of these points are going to be on the same line. But I'll do both of them, I guess, anyways, just in case you don't believe me. I'll show you that they give us the same thing. So for our first one, y minus y, which is 2, is equal to 1/2 x minus x, which is negative 1. Y minus 2 is equal to 1/2 x plus 1/2. Add 2 to both sides. That leaves us y is equal to 1/2 x plus 5/2. And here's the equation. That's 2 that I accidentally drew over. Now let me do the same thing with the other point and show that they will both give you the same line. So y minus 3 is equal to 1/2 x minus 1. y minus 3 is equal to 1/2 x minus 1/2. Now we add 3 to both sides, and that's going to give us the same thing. Y is equal to 1/2 x plus 5 over 2. Same exact thing. So it doesn't matter which one of these points we use. They'll both give us the same thing, and it should make sense because it's saying that they're both on the same line. If you get a different line, then you've done something wrong. And I have one more example. It's not really any more difficult than the other ones. It's just checking to make sure you're paying attention when they talk about undefined lines and lines with slopes equal to 0. Let us find the equation of a line that goes through the point 2, 4, and its slope is undefined. So let's talk briefly again about slopes that are equal to 0 and slopes that are undefined. Let me bring up the slope formula. So a slope that is undefined. Well, let's talk about a slope that's equal to 0 first. A slope that's equal to 0 means that we get a 0 in our numerator. I was about to say numerator. Our numerator, which means that our y's are equal to each other. So that means that y is not changing. So if I had a graph, and I want to draw a line that does not change. When we're calculating a rate of change, there is no rate of change out in the numerator, which gives us a 0. So if these were equal, we get a 0 over some x, which is equal to 0. So that means we have a horizontal line. So you can see that a horizontal line, there's no y change. There's no rise. So over time, we're in the same place. It's like calculating your speed, but you're not going anywhere. You're parked. Time is passing, but your position isn't changing. So that's what that means. When we have a slope that's undefined, that means our x's are equal and we get a 0 in the denominator. So we get some y value over 0. And in this case, our slope is not equal to 0, because you can see here that we are having change, but we can't calculate the change because it's instantaneous. It's an infinite change. It'd be like, I guess if you were driving again and your speed if you wanted to calculate, someone asks, how fast is that guy going right now? He's going infinite speed. Like there's this constant instantaneous change, I guess is the best way to explain it. So we consider it to be undefined rather than a slope of 0. So that would mean, see, look, this would be like your speed graph, just keeps going up. So this is going to mean that we're going to have a vertical line. And let me show what that would mean. So you might ask, how do we plug in an undefined slope into our point slope formula? Well, let me show what exactly would happen if we put this into our point slope formula. So we get y minus 4 is equal to, and we can't calculate the slope because it's undefined. So I'm just going to put m here. but I'm going to show you what happens. Because our slope is undefined, we know that our x values are the same. They're equal. That's the only way, because if they were different, then that means there would be a very slight tilt. And then we have a time, or an x over which we can calculate the change in y. But because it's instantaneous, that means the x's are equal. And in this case, our x is 2, but it doesn't really matter. It's just x minus x, or 2 minus 2. Either way, what's going to happen is we're going to get a 0 here. And anything times 0 is 0. So it doesn't matter that we don't know what the slope is, because it's going to be multiplied by 0. So that's going to leave us with y minus 4 is equal to 0. And we add 4 to both sides, and that gives us 4. Y is equal to 4.